Welcome to this video. I'll be solving this AP Precalculus practice or mock test that I found on crackap.com. And this is on trigonometric functions. Hey, I feel like people struggle with this topic, so I'm going to solve these problems. Hopefully my explanations can help you. Okay, this website does give you solutions. I did not look at them, like the worked out solutions. I'm just going to be comparing my answers to the multiple choice answers that they have. They have a link to look at the worked out solution. I don't know what's in there. I might have to look at some if I don't get a matching answer, like in the previous problem, in the previous video of logarithmic functions. They just did not have the correct choices, actually. But I'm rambling now, so if my explanations are not helpful, I would recommend you go to the website, or vice versa. If the website was not helpful, hopefully my explanations can help. Okay, so let's begin solving the 10 problems here. Okay, so the first one says, which of the following choices are equivalent to the expression cosine alpha times secant alpha minus cosine alpha? So I'm going to distribute this cosine, actually before that, cosine alpha. So secant is 1 over cosine alpha. Okay, we need to know that identity or definition. So now let's distribute the cosine alpha. So it'll be 1 minus cosine squared alpha. And we know the identity cosine squared plus sine squared is equal to 1. So 1 minus cosine squared is sine squared. So it'll be sine squared alpha. Choice C. If the terminal side of angle A in standard position is in quadrant 1, and cosine A is 5 over 13, what is the value of sine A times tangent A? Okay, so quadrant 1's up here. We have some angle. We don't know, but do we care about what the angle is? We probably don't. So the angle is actually A. Okay, they say cosine is 5 over 13. So cosine is adjacent over hypotenuse. Okay, so we want sine A and tangent A. So we need to get this side over here. Okay, so we use Pythagorean theorem. 13 squared is, if I call that side y, it would be y squared plus 5 squared. Okay, this might be a special triangle, but I don't remember off the top of my head. 13 is 169. We need to subtract 25 is equal to y squared. Okay, so 144 is y squared. Y is equal to 12. Technically it's plus or minus, but this is a length, so we just take 12. Okay, so sine of A would be 12 over 13. Tangent of A is 12 over 5. So it would be 144 over, that's 50 plus 15, 65. So the answer is A. If x is a positive acute angle and cosine x is equal to A, which the following is an expression for tangent x in terms of A. Okay, so positive acute angle, so that tells us it's in quadrant 1. Because if we just draw it from like in standard position, so positive we go counterclockwise, and it's acute, so it's less than 90 degrees. Okay, so if we have the angle's x here, cosine of the angle, so the angle's x, cosine is, we can write it as a ratio, a over 1. So adjacent over hypotenuse, a over 1. So this side, by Pythagorean theorem, would be 1 minus a squared. So 1 squared is a squared plus this side squared. So 1 minus a squared under the square root is this guy. Okay? So they want tangent x in terms of a. So tangent x would be 1 minus a squared over a. Choice C. Okay, so you can notice the habits that I always draw triangles to help me out. So do that also. Tangent x is root 3 over 3. Cosine x is minus root 3 over 2. Find the measure of angle x. So we got to find out which quadrant it is. Okay, so cosine, we know, is negative. Okay, so that means it could be either, that's when the x-coordinate, cosine is the x-coordinate in the unit circle. cosine x is negative, so it has to be in quadrants 2 or 3, because this is the negative x over here. Tangent is positive. We know tangent is positive when in quadrants 1 and 3, because here both the x and the y components are positive, so y over x is positive. Over here, they're both negative, so a negative number over a negative number is a positive number, so that's why it will be in quadrant 3 then. Cannot be in quadrant 2 because the x component is negative, but the y component is positive. So a positive over a negative is a negative number, but we have a positive number here. Okay, so does this help us already to eliminate most of the angles? 2 pi over 3 is in quadrant 2. 5 pi over 6 is in quadrant 2. 7 pi over 6 is in quadrant 3. 5 pi over 3, where is that? That should be in quadrant 4. So the answer is C. Graph of which equation has an amplitude of half, period of pi. Okay, so amplitude, if you remember the general form, is like a sine of omega x. Okay, so a is the amplitude. So it should be a half out in front, so we eliminate a and b right away. Now, which one is it? Period of pi. So period would be period, capital T, all right, 2 pi over omega. So that's where the omega comes in, okay? They say period of pi, so let's plug that in. Pi is 2 pi over omega. We solve for omega. Omega would be 2 pi over pi, which is equal to 2. The answer is C. Which the following expressions is equivalent to sine of theta? Okay, so if you know this, cosine and sine are just delayed by 90 degrees. So I can already tell that that is not A and not D. Okay, so now which one is it? Okay, so we can just plug in some points, for example. Or actually, we can even just graph it. Okay, so sine looks like this. Okay, cosine looks like this. Okay, so this guy is pi over 2. So this is where the sine reaches the max at pi over 2. So didn't this shift to the left by pi over 2 for the cosine? So it shifts to the left. That means it is... Okay, so... Okay, we gotta still be careful. So, which of the following expressions is equal to sine of theta? So if we shift... Okay, so actually we're shifting the cosine. So let's think of it the other way, because this is shifting the cosine. If we shift the sine, we operate on this guy, but we're shifting the cosine. The cosine is shifted to the right by pi over 2. So this is the horizontal shift to the right. It'll be a minus pi over 2. If we even check, when we plug in theta is 0. Okay, so sine of 0 is 0. Okay, cosine of, actually these would both be 0 then. It doesn't help us, so we gotta plug in at different points. For example, we can plug in pi over 2. Because sine of pi over 2 is 1. Cosine of pi over 2 plus pi over 2 would be negative 1. That's not right. Cosine of pi over 2 minus pi over 2, cosine is 0. That's 1. So that's right also. So you can plug in points or you can visualize from the graph. Either method I would recommend. Which of the following could represent this graph here. So let's peek at the choices right away. So these are the choices. So it's in terms of sine. So we got to figure out the period and the amplitude again. So what's the amplitude here? The amplitude is 3, because amplitude is defined as how much it goes up or down from the average value. The average here is 0, or the midline, I think I saw in some book. Okay, so we know the amplitude is 3. We can cross out B, and we can cross out D. Okay, so now we got to figure out the period, so we can stay on this page. So period is when it starts repeating itself again. So if we take this peak and this peak, how far apart are they? So, or we can even take this one and this one, because this is the same, it's complete like the upper over here, right? And then over here would be a repetition, it'll be upper over there again. So the difference, the period, is pi. So actually we did it up here. If the period is pi, then our omega is 2. So the answer is A. Okay. A few more. At which value of x does the graph f of theta equals tangent of theta minus pi over 4 have a vertical asymptote? Okay, so if it was just tangent of theta, we know there are vertical asymptotes at x is plus or minus pi over 2 and like odd multiples of that, not even multiples. Okay. Now this guy is just shifted by pi over 4 to the right. Okay, so when we shift it, we get like minus pi over 2 plus pi over 4, which is minus pi over 4. And the other one would be pi over 2 plus pi over 4, which would be like 3 pi over 4, if I did it correctly. Because this is 2 pi over 4. Yeah, so, okay. So this would be a vertical asymptote, so the choice is A. Sine of arc cosine x was the value of f of half. Okay, so these, you got to remember, arc cosine of something gives us back the angle. Okay, so imagine this is sine of theta. So theta would be arc cosine of x. Okay, so as I just said, when we take arc cosine, we get back the angle. So we can even rewrite this as cosine of theta is equal to x. So cosine theta is equal to x over 1. We can even write that as, so 1 would be the hypotenuse, x would be here. Okay, and then we can even get this side as square of 1 minus x squared by the Pythagorean theorem. Okay, so we want sine of theta. So we want, so our f of x would be sine theta, which is square root of 1 minus x squared over 1. Okay, so that's how we get that. And then f of half would be square root of 1 minus a fourth. Okay, so what would that be? That would be square root of 3 over 4, which is square root of 3 over 2. Answer is D. Okay, last one, cosine x is 12 over 3, sine y is 4 over 5. X and y are acute angles. What is the value of sine of x minus y? So you probably need to use the identity that sine of x minus y is equal to something. So let's see if I remember it. Equals to, it's like sine x. Okay, let me see if I got this correct actually. Yes, okay, so we're gonna use this. Okay, so now what do? Let's just start plugging in what we know actually. So cosine x is 12 thirds. Oh, sorry, 12 over 13. Sine of y is 4/5. Okay, we still need sine x and cosine y. Okay, so we have to do similar to what we did in the other problem. Let's draw two triangles. Okay, so x is the angle of one of them, y is the angle of the other. Cosine x is 12 over 13, so 12 is the adjacent, 13 is the hypotenuse. I believe we had this special triangle in the other problem. What was the value here? Let me look at my previous paper. It was, we did it in number 2, the special triangle is 5, 12, 13. So the side over here should be 5. And we know that since they're acute angles, they're in quadrant 1, so we're okay with the number. We don't have to put like a negative or anything like that. Okay, so sine y is 4 over 5, so 4 is opposite, 5 is hypotenuse. 3, 4, 5 triangle, that's the easy one to remember. So 3 is over here. So we get sine of x is 5 over 13. Cosine y is 3 over 5. Okay, so now we just simplify. This is what, 3 over 13 minus, this is, do we have to do all this work? Okay, let's do it. 13 times 5, that's 50 plus 15, that's 65. Okay, and actually maybe let's not simplify over there, but let me continue first. This is 40 plus 8, so 48. Okay, let's keep it in unsimplified form, 15 over 65. So this is minus, what's 48 minus 15? That is 33, right? So minus 33 over 65. And the answer D, it is. Okay? It's a typical problem that I see, even in like college pre-calculus. It's this type of problem where you have to, when they want you to use the identity and then they only give you half of the information. So you got to find the other half also. Okay? And that's it. That was not too bad, actually. So trig is actually not too bad. People get confused by not drawing triangles out. And when it's like arc cosine or arc tangent, you're getting back an angle. Those are the few concepts that people tend to miss or forget. And don't have the habit of drawing out triangles. Like, you see, almost all the problems, I drew out something. So just visualize by drawing things out, okay? Don't be lazy, even though it's multiple choice. Okay, please like and subscribe as always if you found this helpful. And please be on the lookout for the next video. I'm not sure what I'll be doing next. And if I have time to post another one, but hopefully I do, and please be on the lookout for that if so.